Good morning, and thank you for your patience in waiting on us. Welcome to today's webinar, Improved Digital Prototyping Workflows with AnyCAD, Nastran In-CAD, and Vault. This webinar is brought to you by LiveLabLearning, which is a subsidiary of Academic Corp, a wholly owned applied software company created to provide world-class training. This is Amy Berry, and I'm delighted to be your moderator today. Throughout our presentation, we encourage you to interact with us by typing in questions and comments using the questions pane. We will be answering questions at the end of the presentation. This webinar is being recorded and will be available to you online on our YouTube channel. If you haven't already, search LabLabLearning on Facebook and like our page to receive the latest information and special offers. When you visit our website, LiveLabLearning.com, there's a complete schedule of upcoming training. Please join me in welcoming today's speaker, Jason Miles.
Thank you, Amy. So what we're going to end up doing today, let me go ahead and minimize some of this, is we're going to be looking at a workflow centered on a few of our 2016 products that will include Inventor Pro, Vault Pro, and Nastran In-CAD. So what we're going to end up doing is we're going to make some changes to a bell crank assembly here on our model from Briggs Automotive, and I want to go ahead and show you what we're going to be using. And you'll notice this is the bell crank that we're going to be dealing with. So we're going to start out in Vault Professional, and we're going to be taking a look, first of all, at an ECO, which is requesting us to take out about 20% of the weight of this bell crank assembly. And also, you'll notice here that with this ECO, we have some pertinent files that can be attached. So let's go ahead and take a look at this front rocker report here. Now, as I scroll through here, we can see from the attached analysis report here that was included in that ECO that it looks like this part is performing fairly well, but we can see that it has a safety factor that's a little bit over 4, but we want to see if we can reduce this weight and still keep our minimum safety factor of 2 as well. Okay, so let's go back to Vault, and we'll take a look at this rocker assembly here in Inventor with our preview. So within this assembly, we're really going to be focused on just this rocker portion here of the assembly. All right, and then also within Inventor, we can also in Vault Professional, we can also take a look at the drawing that's associated with this rocker as well. So I'm going to go ahead, instead of having to search through the folders, I can actually go within Vault Pro, go directly to that folder. And what we're going to end up doing is we're going to utilize the uses functionality here, and it's going to allow us to isolate these components for this main assembly by utilizing the copy design function of Vault Pro. Okay, once we're in here, I want to actually go ahead and let's make sure we have mono part numbering. We're going to use that numbering scheme that was set up for this particular project. And I'm going to actually just copy the top level bell crank assembly and then also the rocker. Okay, and here we're going to go ahead and choose copy. And we can see, however when we copy this over, I need to change the functional category because this particular component is in our front suspension folder. So I'm going to go ahead and change this to front suspension. That way it'll automatically go to that folder. Okay, so once we have that, we can go ahead and Vault will automatically copy the design as well as any linked drawings or other documents and assign these new sequential part numbers based on these functional areas to these new components. Okay, once we have that, we can go ahead and close out of the copy design. And then once these are copied, I'm going to scroll down here in my suspension front folder, and you'll notice there are these newly created parts and drawings, and they have obtained a sequential part numbering scheme. Now, one other thing that I want to do is I want to actually go to my engineering change order, and I want to actually respond to this ECO, and I want to change the workflow status here to work in progress, that we're going to be working on this. So I need to let everyone else in the work group know that we're going to be working on this particular part. So I'll go in here and I'll maybe type in a comment incorporating changes from this ECO here. And I'll go ahead and say OK. Now once we have that, I'm actually going to go back to my the part that we're going to be working on, and I'm going to open up this particular assembly. And yes, I am going to check it out of the Vault. So we'll notice here, since I'm wanting to focus on this rocker here, I'm going to activate this rocker, and I'm going to move this into part marker up above my body 1. Okay. Now the reason I'm doing this because I want us to take a look at a new functionality in Inventor 2016, which we refer to as DWG underlay. So I'm going to go ahead and I'm going to insert a CAD drawing. Okay, and what it's wanting me to do now is just select a work plane to place this drawing on. And then I'm going to grab this center point here. And you'll notice here that it's given us a message saying that any of this geometry can be projected to be incorporated into our new design. All right, so now that we have this inserted, the next thing that we're wanting to do is, first I want to point out that this is not the same as using AutoCAD data. So in the past, where you basically performed a cut and paste from a DWG file, and then you would drop it into a new 2D sketch, and then you would create geometry from it. So this rather is a truly associative DWG, which means if anything changes on the DWG, let's say in AutoCAD or AutoCAD Mechanical, it will change in Inventor as well. So it would update any of your geometry or solid geometry that you are referencing from this 2D data. So let's go ahead and orient this. Okay, now another thing that this allows us to do, so we have a lot of text and everything showing, which I really don't need to show or utilize. So I can actually come in here on this drawing and I can control the layer visibility of the imported 2D data. So this will allow me to kind of filter what I'm wanting to see. Instead of checking everything here, I'm just unchecking the hatch and the visible ANSI, and I'll do an invert selection. So we'll have the geometry that I'm needing. Okay, the next thing that we want to do is I need to locate this geometry that I'm going to be using. So I'll translate this. So now we have it located. So what we'll end up doing is I'm going to create a new 2D sketch within this part. And I'll choose my XY plane once again. And you'll notice that with this new capability of inserting a DWG underlay, I also have the ability of projecting DWG geometry. So with my mini toolbar that's up, we have the capability of choosing or projecting single geometry, connected geometry, or also DWG blocks. So I'll go in and grab some of this geometry that I want to keep and project. Okay. Like so. So that looks good. All right. And I'm going to finish this sketch, and there's a couple other pieces in here that I want to turn on. There we go. And I'll go back in and continue projecting this geometry here. Okay, that looks good. So we'll continue. Now, before I finish this sketch, I actually want to project a few other things here. This is the section view of that rocker, and I'm going to grab some geometry here as well. And with that being projected, I want to actually go in here and I want to place some driven dimensions that will assist us when we start extruding some of those profiles. Okay, once we have those, that looks good. We'll finish the sketch. Okay, now that we have referenced the geometry that I'm wanting to utilize, the next thing that I'm going to do is I'm going to turn off the visibility of our DWG. So we can go ahead and go in here and just turn off the visibility like so. And then we can start extruding some of these features. So I'm going to grab, let's say, these closed loops here, like so. And I'm actually going to extrude this up, the overall height, where I'm going to reference one of these dimensions here. Okay, once we have that, I'm going to go ahead and let's actually, with this height, since I can utilize the mirror capability in Inventor, let's just go ahead and then extrude this just half. That way it'll make the modeling portion of this a little bit simpler. All right, so I still want to utilize parts of that sketch, so I'm just going to turn the visibility back on. Let's see here. And actually I can turn this sketch 5 back on just by dragging it up above my extrusion 1. So here what we need to do is I need to cut out some of these areas here. So I have 3 areas that I'm going to end up cutting out. So on the first one here, I'm going to, let's go back to extrude. And we'll cut this going in referencing that geometry over here. So we'll do that with this 24.36, and we'll change it to a cut. And let's see what we have here. Okay, and since it's half, remember I need to divide it by 2. So there we have that distance. We'll just continue on referencing the geometry on the other pieces as well. So this will be a cut divided by 2 since I'm only doing half. And then lastly, let's grab this last closed loop. Okay. So now that we have those, we're going to go ahead. Let's turn the visibility back off of this sketch 5, just so it cleans it up so we can see a little bit better. And I want to add some fillets to some of these edges here, just to soften up some of these edges. So I'm going to grab, let's say these 4 here, and I'm going to apply a fillet of, let's say, 7 millimeters. That looks good. And then also, maybe I want to clean up this edge here just a little bit. So we'll place a fillet on this edge of 3 millimeters. And then also, I want to add some fillets in here inside on these pockets. So I'm going to grab those as well. And we'll set these up to have a radius of 1.5. Now the next thing that I want to do is let's look at the capability of using open profiles to create a feature here. All right, so I'm going to actually create a sketch here on my YZ plane. So it'll be going straight through our part here, or our XZ plane, I'm sorry. So I'm going to create a new sketch, and I'm going to project some geometry here and then we'll go in and I'll sketch some geometry that we'll utilize to create a revolve cut. I'm going to sketch a line going over here to the side, somewhere around 160 millimeters. And then for the angle here, I'm going to apply a dimension, and I'm going to set this angle to be 86 degrees. All right, so once we have that, we're going to create a conical cut on the top of this rocker by using the revolve command and utilizing this open sketch. Okay, so we're going to utilize this profile here. My axis, I'm going to utilize the Z-axis. I'm going to make sure it's going to be a cut, so we're going to cut away material. Let's go ahead and say OK. So there's our conical cut. All right, so I'm going to utilize some more of that sketch 5 that we created by projecting from that DWG overlay. So I'm going to turn that back on. And I'm going to add a few more features now using some of the geometry that is existing within this current assembly. So let's go ahead and let's section this rocker assembly here. So I'm going to create a half section. We're going to section it right here through this XZ plane. All right, so next, what we want to do is I'm going to create an extrude here. And so I'm going to grab some of this existing geometry, and I'm going to, for this extrusion, and I'm actually going to terminate it to one of the components in the assembly. In this case, the seal and the thrust bearing. So this is going to be a 2. I'm going to extrude that to that face there. All right, so there's one extrusion, and let's perform another extrusion here. And it's also, I'm going to extrude it to a face already in this assembly. Okay, we'll edit that because we need to add material, not cut. So there you'll see we have those two extrusions here within our bell crank assembly. Now the great thing is, by us utilizing this DWG underlay, is it's automatic, it's accurate, and it's built off of the existing geometry. So it really doesn't get any better than that. So I'm going to go ahead and let's turn off the visibility of this sketch 5 once again. Okay, the next thing that I want to do is I want to go ahead and mirror this portion of the rocker to complete that rocker part. Okay, you'll notice that it has already grabbed our geometry because I'm mirroring a solid. And I'm going to choose this top plane here. And there we have it. So I'm going to go ahead and let's return back to our top level. Now, the only thing that we have left to do now for this rocker part is to add some content. In this case, I'm going to place some content from the Content Center. And what we're going to be utilizing is a shaft part. So I'm going to go ahead and I'm going to perform a search. And let's search for SKF. And what I'm looking for is actually a DIN 617. Okay, let's see what this one here is. Flanges within a ring. Okay, that looks like that'll work. And since I'm using the auto drop, the only thing that I need to do is I need to select or pick the cavity into which this Content Center part is going to be placed. So that looks good there. Then I'll go ahead and grab that. Now the next thing that I want to do is I want to change the size. So this will allow me to select from the family the specific model number. And let's go down and let's see if I have a 28 by 20 TN. And we do. So I'm going to go ahead and place that. All right, so there's our Content Center part. So I'm going to go ahead and let's finish this or end this section view. All right, so pretty much our bell crank assembly is done. So let's go ahead and save what we have. Okay, now one thing I want to point out is we can actually query within Inventor, the Vault browser. We can also go to our model view and we can actually open the drawing that we perform the copy design on that is associated with this part. Okay, so what I'm going to end up doing, I'm actually going to go to our Vault within Inventor, and we'll go down to our suspension front folder, and we'll notice here that I have the new files that I have checked out. And we can also find the drawing associated with this, since it did perform a copy on this part for the drawing. So I'm looking for the 1144, and we have it. So let's go ahead and open this. So with this being open, I actually want to make a few changes here within this document. And what I'm going to end up doing is we're actually going to add a parts list and also some balloons that reference that parts list. So we can get that placed in there. Then we'll also go ahead and go to our auto balloon. I'm going to place these vertically over here to the side. And there we have it. Okay, so I'm going to go ahead and save this drawing. Now let's go back and take a look at Inventor's new home screen. You'll notice here in the home screen, we actually have a refresh vault status. So if I come in here and look at this, you'll notice that since I've checked out the drawing and the bell crank assembly, notice I have a little check. And then also, we want to open up another assembly. Now you'll notice here that this assembly does not have a check in it. So it's letting me know that this is available for checkout. So let's go ahead and open up this assembly here. Okay, and I'm going to go to the Vault browser, and I'm going to go ahead and check out this assembly. Notice I'm doing this directly in Inventor. I'm not having to switch over to the Vault Professional window. Okay, notice we have it checked out. Now, what I'm wanting to do is we're going to actually be replacing this current bell crank assembly with our newly designed bell crank assembly, which is, we made some cutouts in it, which is going to make it a little bit lighter. So here I'm going to be actually going to the Vault, and we'll notice that I have my bell crank assembly located here. All right, so there is our newly designed bell crank assembly. Now the next thing that I need to do is I'm going to add a few joint constraints to go ahead and lock this assembly down. So I'm a big fan of using these joint constraints. All right, so there's one. We're going to continue and get these other two. Okay, so now we have that fully constrained. And then what I could do here is if I open up, sort of clean this up a little bit in here, I'm going to actually turn off the visibility of some of those sketches that I have. Okay, so that looks good. And let me go back and save this as well. Okay, all that looks fine. Now, once we have this cleaned up, what we want to have in here is actually, we need to, or at this point, we need to actually find out if this new design is going to function and do what it is supposed to do. And we can do this by utilizing Nastran In-CAD. Okay. Now here in Nastran In-CAD, this is directly within Inventor. It's located underneath the Environments tab here. So the first thing that we want to do is we want to start out by constraining this model. Okay. So we're adding some constraints. We want to add a load as it is in the suspension assembly with the load from the push rod through these two holes here with a load of 5,000 newtons. Okay, next we are able to constrain using some special case constraints. In this case, it is a revolute joint, but is a revolute joint that acts on that interface there. And then we'll add, so we will release the rotation so that the axis indicating to the solver that this part is free to rotate about that axis. So you'll notice we'll hit the mesh, we'll run it. So once it's done, we are ready to take a look at some of our results. So let's take a look here at our stress von Mises, and you'll notice here that it had a max of 144 megapascals, which isn't critical, but we'd like to reduce that if possible. All right, so next we'll look at our factors of safety, which we had, and we noticed that we had it below 2, and so that's good, and because we were wanting to have a minimum factor of safety of 2, so we were in that range. So the next thing that we want to do is we'd still like to reduce some of these stresses. So we're going to set up a fatigue study. Okay, so what we are getting ready to do now here is we are evaluating the design of the part as it is right now. So we want it to survive an entire season of racing. Ideally, we'd want it to get an entire season out, which is 8 or 9 races out of that bell crank assembly. And as you can see, that this part sees a lot of stress. So by having a tool like Nastran In-CAD, this allows us to evaluate without having to build a physical prototype. Okay. Now, before I continue and go on, we want to further make some modifications to this part. And what we can do is let's go ahead and let me launch AutoCAD Mechanical. So with those changes that we did in Nastran In-CAD to improve the fatigue, it improved the fatigue life of the part, so we can do a little bit better. So let me go ahead and log into the Vault within AutoCAD Mechanical. Now remember that DWG underlay is associative to our Inventor part. So I'm going to go ahead and we are going to open that DWG. Okay, so here once again, I'm going to more or less isolate some of the geometry here because I'm going to make a modification to this newly created bell crank. Okay, so we're going to actually stretch these cutouts here. I'm going to stretch them up maybe just a little bit, maybe about 10 millimeters, like so. So once I have that, I'm going to go ahead and unisolate some of those layers. And I'm going to go ahead and save this. All right, let's return back to Inventor. And let's look at our bell crank, and I'm going to rotate this around just a little bit so we can see these changes. So you'll notice that I have a lightning bolt up here at the top. Okay, so let's update it. And you'll notice that that geometry changed because it was an associative DWG underlay drawing. Okay, so those changes have been made. So we could take this a little bit further, and we could actually go in and maybe do some more modifications to our design. Okay, so let's go ahead and activate our rocker. And I'm going to go in and utilize that sketch once again. Okay, and let's extrude these cutouts that we have. Maybe it'll give us a little bit more stability for our part. And I'm going to extrude that, let's say 5 millimeters. Okay, well, let's do this first. Since we did a mirror, I'm going to actually move my end apart up above that mirror. There we go. Now let's do this extrusion here. 5 millimeters. That looks good. And then also, maybe I want to add some fillets inside here. So let's see if I can add some fillets. Okay, I'll tell you what, let's leave those fillets out for right now. This could be part of going through and performing the Nastran to see if possibly maybe want some fillets in here, see how it would act for our simulation to play with two different scenarios. All right, so once we have that, we'll go ahead and end the part marker back down below my extrusion. That way I'll have a total rib in here of 10 millimeters. So that should strengthen up this part pretty well. All right, so I'm going to go ahead and return back to the top level. And let's go ahead and save what we have. All right, so once this is completed, we can then go into our Vault browser. I'm going to check in this part, and maybe I want to go ahead and enter a comment to include with this version. So I'm going to say incorporated changes to bell crank assembly per ECO and analysis results. Okay. So notice we're checking it into the Vault. Notice the status here, it's no longer checked out. So it's telling me that it's available for checkout. So we can go ahead and close out of those components. Notice, same here. It has those updates already. Go ahead and save this as well and update it. Just making sure I'm saving everything. And then we'll notice that this also has my changes as well. So we'll go ahead and check in this drawing to the Vault. I'm going to go ahead and close this drawing as well and delete it from my current workspace. Just making sure we're checking everything in. Notice there while I was checking in, there's the modification that we just done. And then lastly, once this completes, then we'll go back and check in that drawing. And then we'll go take a look at in the vault and do a refresh just to verify that everything was checked in. Let's go ahead and close out of this. Okay. All right. There we have that one checked in. This one is checked in as well, available for checkout. So now, let's refresh some of this status. Notice everything's checked into our vault. And then also within Vault Professional, if I do a refresh, we'll notice that those components were checked in as well. So I hope you can see that with this workflow that we've seen today, how beneficial it is to be able to utilize some of the new features as the DWG underlay. Also, one thing that I want to point out with what they call as AnyCAD and DWG underlay as a part of that, you also have the capability of referencing non-native Inventor files such as SolidWorks, Pro-E, Catia, within an Inventor model. So we know that we have certain companies that might have a mixed environment where they might have SolidWorks and Inventor. So this allows them to actually utilize the AnyCAD technology by bringing in like a SolidWorks model into Inventor. And if any changes are made within SolidWorks to that part that is being referenced in the Inventor, those changes will update. So it has that associativity once again with this new AnyCAD technology. And then also the benefits of having Vault Pro and the capabilities such as an engineering change order with files attached to it to keep all those files together in one nice and neat workspace. And then, of course, also being able to do your own simulation utilizing a tool such as Nastran In-CAD to validate your design and cutting down on some of the physical prototypes that you might have to create. So with that being said, I'd like to go ahead and turn it back over to Amy for any questions and closing comments.
Thank you, Jason. Can you hear me?
Yes.
Great. Thank you so much for that in-depth presentation on the workflow from using AnyCAD, which brings in lots of different file formats, through Nastran, and also the value of Vault in that environment. Do not see any questions at this time. Let me remind you that you can post a question in the question pane, and we can address that at this time. I'll give a few seconds for that to see if any come through. Well, Jason, I guess you did a stellar job because there's no questions here. If something does come up after this that you do have a question, feel free to email us or call us. The information's there on the screen. Also, I encourage you to visit us at LiveLabLearning.com. We have a full list of all our training classes and information regarding those training classes. Thank you for joining us today. We hope you found this webinar informative and helped to your business. We are finalizing next quarter's webinar schedule, so watch your email for more details and feel free to reach out to us with any questions or concerns on today's technology or that was shown or any additional needs that you may have. Thank you.